Good afternoon to everyone. So I'm going to talk about the first topic of today, the IPv6. I will talk about some basics. It's the IPv6 menu addressing and auto configuration. So we know that once you have the computer connected with a cable, the first thing you may need to do is finding the IP address for your computer. Okay. So there are a number of ways you can find the IP address. You can do it manually, or you can use the DHCP to do auto configuration. But today we are going to talk about the IPv6, which is slightly different from the IPv4 in terms of configuration. You learn some new commands. You also learn some new features of IPv6. So let's take a look. So this is the topology I'm going to start with. A very simple topology with 3 routers and 3 PCs. And after I finish my part, Anand and Liu Khan will continue to talk about the IPv6 configuration for static route and also the dynamic routing with the same topology. So the first part I will talk about in this menu IP addressing configuration for IPv6 is that you can assign a manual IP address to the PC and a router to form the basic communications. So once you have the IP address configured, you will be able to ping between these 2 devices. So this is very simple, it's very basic, like the IPv4. You have the IP address assigned to the network devices, and the next thing is you can start to ping them to verify the layer 3 connectivities. Okay, simple and easy. And the second thing I will talk about in this demonstration is I'm going to do some automatic addressing. It's like DHCP, but it's not exactly a DHCP. IPv6, you do not need DHCP, although you can use DHCP to do automatic IP address assignment. But the IPv6 comes with the native automatic addressing capability. So you can assign an IP address automatically on a router interface. So you don't even need to assign a static IP. You just tell the router that this is your subnet, the prefix, and please generate an IP address for me. And the PC, only a single button. You turn on the auto configuration, you will be able to get the IP address from the router. Very simple and easy, just like you click the DHCP button. But IPv6 is auto configuration. Okay, and the last thing I'm going to talk about in this topology is the link local address. So in the IPv4 world, I think you have experience like when you want to get an IP address from the DHCP, but the DHCP is not responding for many reasons. This could be the DHCP server down, or it could be like the interface spanning tree 30 seconds problem. You are not able to get the address from the DHCP server. And what will the system give you? You still need an IP address to communicate with each other. So there's something called link local address in IPv6. It's just like the IPv4, when you are not able to get the address from the DHCP, the system will give you an IP address like 169.254.0.0/16, like in Windows. You still have an IP address. Let me put a pointer here. You still have an IP address, but this IP address is limited to the local segment only. You have an IP address to talk to other devices on the same segment. It's not routable, but you can at least do a communication with your router, with your peers' computers. So in IPv6, we also have this concept called link local address. You'll be getting an IP address just for the local segment communications. So I'm going to show you how to get this address, how do you assign this address, and where you can check the configuration or the router status, and then find out what's the address of this interface. So I'm going to do 3 demos in this demonstration. First is manual addressing, the second is automatic addressing, and last one is the link local address. So I'm going to turn to my packet tracer screen and start with my first demo, manual addressing. Okay, let me share my application. Okay, it's coming up. Okay, I'm sharing my packet tracer. So before I move on, I'd like to to ask if you can see my screen sharing. Can you raise your hand? Let me know. Both voice and the audio and visual is okay for me to move on. Okay, thank you very much. I see many hands. Okay, so this is the basic topology that I showed you earlier in the PowerPoint slide. So we have this topology, but there is no configuration. So the first part is the manual addressing. So let me do some addressing configuration on my router. Okay, so this is my router. I simply enable the router to the privilege mode. So this is an Ethernet connection. I'm going to go to the fast Ethernet interface to do an IP address configuration for this interface with IPv6 address. So first of all, I go to the config mode. I usually also turn on the IPv6 unit class routing to enable this router to be IPv6 routing capable. So let me enable this IPv6 unit class routing command, and then I can go to the fast Ethernet interface to do my first IP address assignment for this router fast Ethernet interface. So usually in the IPv4 we do an IP address command with a bunch of numbers to configure the interface IP address. But in the IPv6 configuration, we are using this command. It's called Ipv6. So this is one of the key difference when you configure the IPv6 address. Make sure you put the v6 command instead of just the IP command. Ipv6 command is the command you use to assign IP address to the interface. So once you enter the IPv6 address command, you can put a question mark and see what is available there. You see a number of options there. You can assign the link local address as I mentioned earlier on. You can also assign the IPv6 prefix, and there's one thing called auto configuration. As I'm going to do a manual address assignment, so let me give a manual addressing. So start with 2001. So this is the IPv6 address for global unit class routing. So you need to have IPv6 address on your interface. But there are at least three types of IP address on the interface. Which one you need to assign? So if your computer or your host, your node, is going to be like internet routable, you need to assign a global unique address on your interface. 2001 is the IP address range that used globally for IPv6 routing. So you put an IPv6 address 2001, and I put the address, so to make it easy, I put it 1. Means this is the first segment of this network. And I give the IP address all the way to 1. So you see there's a 2 colons. Means that there are a number of zeros there that is shortened to be 2 colons. So you don't want to put many zeros in the command line. To make it easy, you can just put 2 colons that represent that there are a number of zeros in between this colon, that you can suppress it to make the IP address shorter. The next thing in the IP configuration in IPv4, after you enter the address, is the subnet mask, right? In IPv6, we do not use the dot notation way to enter the IP address, the subnet mask of the IP address. We use the slash with the number of bits to represent the length of the subnet mask. So in this example, I put the 64, means that the first 64 bit of this IP address is the network address, is the subnet prefix, and the remaining 64 is the host address. So I hit enter, and now my router interface has an IP address. So how do I know if this IP address is configured properly on my router? We use the show IP interface brief command or show IP interface commands in IPv4 configuration. In IPv6, it's very, very similar. So let me do a show IP interface brief. But again, this is IPv6, it's not v4. So you have to put a v6 command instead of just the IP. And because I'm now in the interface configuration mode, I need to add a do command for me to execute the command while you are in the interface mode or global configuration mode. And now you can see I have two addresses. This one I'll explain later on. What I'd like to show you here is the address of this interface. I just configured the IP address for this interface 2001.1 for me to show that this is the first segment, and with two colons means that there are a bunch of zeros in between these two colons, that I suppress it with two colons, and this is the host address is actually 1 here. Okay, I make it simple. So I'm going to assign a similar IP address for my PC to form the basic IP layer connectivities. Okay, so I will also need to enable the IPv6 on this interface, so I do an IPv6 enable. And now I go to my PC. So if you go to a PC, you configure IPv4 for virtual PC in the Cisco Packet Tracer, you do an IP configuration. But this page is only for you to configure IPv4. Okay, if you want to configure the IPv6 on Packet Tracer, you need to do a little bit differently. So you go to config, instead of the desktop, you go to the interface. You see we have the IPv6 configuration option here. So you can assign the address in the DHCP way, in the auto configuration way, or you can do it static. So I assign the IP address to the same subnet, is 2001.1, and this is the second address of the subnet. So the router is 1 and this one is 2, and that's it. That's all I need to do to assign the IPv6 address plus the subnet mask. So it's 64 bits length of the subnet prefix, so I just leave it 64 by default. And I can go to my PC. Again, if you go to the IP configuration page, it's empty because this one is for v4, it's not for v6. So how do you know whether your IP address is configured properly on a Packet Tracer PC? So you can go to the command prompt. In v4, we do an IP config command. You see all zeros there because this is for v4. So to show the v6 IP address, you need to do an IPv6 config. And now you see I have the IPv6 address configured on this PC. And this is 2001:1 first segment, and with two colons in the middle, means there's a number of zeros suppressed. And the host address is 2. With my cursor moving over this number is the host address. Okay, now I can do a simple ping to verify the connectivity of the IP configuration. So this is my PC, this is my router. Okay, I'm going to do a ping. The address is 2001:1:2. 2 is my PC, so I just try to ping myself and see whether whether the ping command is working, and secondly, whether my PC have the proper IPv6 address configuration. Okay, I can ping my PC, I can also ping my router. So now you see that I'm able to form the basic communication in the IP level between my PC and a router. So this is the manual addressing for the IPv6 configuration for router and PC. Okay, simple and easy. So what you need to remember from this demo is that first, the IPv6 address format is different. It's used colon instead of dots. It's 128 bits. And you need to assign the IP address with the subnet mask, not in dot notation, but with the slash number of bits. So in this example, it's 2001, and then slash 64 bits. So it means the subnet is 64 bits. And secondly, when you do all these command configuration on a router or PC, you do not use the IP command. You use the IPv6 command. So make sure you use the IPv6 command to configure and verify your configuration instead of just the IP. Because when you do IP, it's always v4. Alright? So this is the manual addressing demo. And the next part, I'm going to do some auto configuration here. So manually assigning an IP address is easy and simple, but you do not want to do when you have like 1,000 hosts in your network. Okay, even more than 100 hosts, you do not want to deal with that. So in v4, we have the DHCP options. We put a DHCP server, or we make our router to be DHCP server enabled. But in V6, there is a native way to do automatic address assignment. You do not need a DHCP server, or in short, you don't even need a configuration for the automatic IP address assignment. You only need to do some very simple things on a router. So let me turn on this router, and I'd like to show you that show run, enable, show run. So this router, I have the fast Ethernet interface configured. Actually, there's no configuration. It's connected to the PC. I like to assign the IP address to this interface. So in the previous demo, we manually assign an IP address. In Ipv6 auto configuration, there's a very interesting method to assign this IP address. You don't even need to assign a static address. You can ask the router to get an automatic IP address by itself. Very simple and easy. All you need to specify is the subnet. What is the prefix for the network? So let me go to the configuration. I do a config. I need to do an Ipv6 unicast routing. Remember? Enable the Ipv6 routing on the router. And I go to the interface mode. So this is my interface. If you still remember, we did the Ipv6 address command, right? And then we can put a question mark. So here we can specify the prefix. One very interesting way is that we can specify only the network portion. And for the host portion, we leave it automatic. So let's say I do a 2001:2, means this is the second segment in this demo. And I put one more colon, means that there are a number of zero in between this colon is suppressed. And I can put the subnet, the number of bits for the subnet mask. So now you can see that I've specified the network portion. There's no host address. Okay, I only specify the portion, and if I put one more question mark after this address and the subnet, I see one more option here. It's called EUI64. So what is this EUI64? Is the host address or the interface identifier that represents in 64-bit way. So I enter the EUI64. It's a very simple command: IP address, IPv6 address, the subnet, the prefix, and number of bits for the subnet, and put EUI64. And I hit enter. And don't forget, you put an IPv6 enable to make sure your IPv6 is enabled. Now I go to the show IPv6 interface brief. Oh, again, you need to do a do. Okay, so it's 2000:001:2, and here is a bunch of numbers that I didn't enter. But now my router interface has an IP address, has a unique routable IP address. What is this address? And where does this address come from? In fact, that the router or in Ipv6, there is a way to do an auto IP address configuration, or we call it stateless auto address configuration. So you can ask the router to generate the address automatically, and that is a unique address. It will not conflict with other hosts. So you see this number looks very strange. All right, we have numbers. We have the F, which is the hexadecimal. So how is this address generated? So the address is generated automatically. It's based on the interface MAC address. So if I do a show, interface /00, you see I have the fast Ethernet interface MAC address here. So this is the MAC address of my fast Ethernet interface. It's 006070884501. Okay, and if I do a show Ipv6 interface and see what the address looks like, 4501, right? This is 4501. So it means the automatic IP address configuration, how the router determine the unique IP address for this interface, is based on its own MAC address. But you know that our MAC address is 48 bits, right? Any MAC address for fast Ethernet is 48 bits. But for this interface address, the host portion, is 64 bits. And you can tell from the name the EUI64 means 64 bits. So how do we convert this 48 bits to 64 bits? So if I go back to my slide at this point, let me stop my sharing. So in IPv6, the EUI64 interface identifier, it makes use of the 48-bit MAC address from the interface. So each network card is supposed to have a unique MAC address, right? So it takes this 48-bit MAC address and insert FFFE address in the middle of this MAC address. So it means the address will become 009027 FFFE 17FC0F. So the first three components of this 48-bit address is the OUI. The OUI represents the manufacturer, and the last three parts of this address is representing the serial number of the network card. So from here, with this additional address is called FFFE. You put in the middle of the MAC address, it will become the 64 bits of the interface identifier. And there's one more thing you need to do, but of course the system will do it automatically, is to change the 7th bit of this address from 0 to 1. So end up you will get the address like this one in my packet tracer demo. Now I go back to the packet tracer demo. This one, share. Okay, so I go back to my router 2. Okay, so this is my router 2. So let's verify the IP address for this part. Or I can do a show IPv6 instead of the brief, I show some details. Okay, here we can see that the address that automatically generate, we don't need to worry about the first portion because it's network portions. We take a look to this address, the interface address. So it looks very similar to our MAC address because this MAC address is generated from the MAC address. So you see that the first few parts of this address is the OUI from the MAC address, 26070. Okay, let me go back to the MAC address. 00607088. So the first two are 0. If you convert it to the binary format, as I said, to convert the MAC address to the EUI64, the 7th bit will be changed from 0 to 1. So end up you will get the address like this, is 26070, and it inserts the middle part of the address is FFFE, and then the rest will be the serial number of the MAC address portion. So now your router has a interface address automatically generated. So all you need is just to specify the network portion and tell the router you use the EUI64 way to automatically assign the interface address to the router. Very simple and easy. So your router now has interface address. What about your host? Okay, your router is now IPv6 address configure, is ready. What about your host? If you go to a PC, you go to configure, you go to file CVNet, and you change it to auto config. So once I change it to auto config, actually what happened behind this button is that the PC will send a request to the router and asking for the routing information. The PC will send an ICMP message to this router. Of course, the ICMP is for V6, is ICMPv6. And the PC will ask for some routing information from the router. And the router will tell that, okay, this is my interface address, 2001:2 is the subnet, is the network address of this IPv6 address. And you need to determine your own address for the interface portion, for the interface identifier. So you can see that the rest part of the IP address is also a bunch of the hexadecimal number, but it's different from the router because the PC will use the same way as the router did to generate an IP address for its own interface. So this address is actually from the PC's Ethernet interface MAC address. So take a look to this address. This is the PC Ethernet interface address is 0060 5C744CD4. This is the PC MAC address. And the PC used this auto configuration method to obtain the network portion from the router and use the EUI64 to determine its own interface identifier, the host address in the network. This is exactly the same way as I showed you previously how the router determined the interface address with the EUI64 way. So now my PC and router, they both have the interface address, the Ipv6 address, and they can now ping each other to form the communication. So let me do a simple ping here. Let me obtain the IP address from the router. Okay, this is the IP address from the router, and I do a copy, and I open my PC desktop command prompt, and I can paste this address, and now I'm getting the return, the ping reply from the router. So no configuration on the PC, just turn on the auto configuration. You can obtain the IP address from the router and determine the interface address automatically based on its own MAC address. So this is the Ipv6 way of the auto address configuration. We call it stateless auto address configuration. So this is my second part of the IP address assignment in this demo. And I told you that there is the last part of this demo is the link local address. So when I have two devices, if I need a basic communication, I need an IP address. So in Ipv6, there is one address called link local address. It's for the device to communicate within the segment. Within the segment only, that they can communicate with each other. That is the address not routable. It's like the private address, or it's like the link local address that I showed you earlier on in the slide. It's 169.254.0.0. Like in the Microsoft Windows, when you are not getting the address from the DHCP, the system gives you an IP address, 169.254. That is not an internet routable address, but at least that address gives you the capability to have an IP address to start the communication. So if you have the link local address, you can talk to any device within the same subnet. So what I need to do is, like I go to my router interface, I turn on the Ipv6 unicast routing as usual. I go to the interface mode. All I need to do, I don't even need to enter IP address. All I need to do is just Ipv6 enable. Okay? And let me do a show Ipv6 interface. Okay? And now you see my router has an IP address, the Ipv6 IP address on its interface. It's Ipv6 enabled, it's a link local address, and the address is very long. So any address start with FE80 is the link local address that for the device to talk to each other within the same subnet. But what about the other part of the address? How does the router know that this address can be used and this is the unique address? Exactly, it's the same way in the auto configuration I show you. It uses its own MAC address to determine what the address that this interface needs to use in order to generate this link local address. So once you enable the interface, or once you configure a static or auto configuration IP address for the interface, at the same time, the router will generate a link local address. So in the previous demo, like this router, the router 1 in this, let me take a router 2. Okay, in the router 2, when I do a show Ipv6 and Ipv6 interface, you see that other than the global uniclass address I specify in the configuration, I'm also getting another link local address automatically. I didn't do anything to configure this address. It just generates automatically. So you see we have this IP address. And the interface portion of this IP address, they are same as the address ID in the auto configuration, because both of these addresses are generated based on the MAC address and convert it to EUI64 format. So let me go back to this router. My router now has the link local address, right? And I have my PC. I go to configure and fast Ethernet. You see I have a link local address. This is also an address automatically generated from its MAC address. So with these two addresses, I have my PC, I have my router, and both have the link local address. They can at least talk to each other. So let me show a quick ping from my PC to router. I do a show Ipv6 interface, and this is the link local address. I do a copy and go to my PC, desktop, command prompt. I do a ping, paste this address. SE80 is the link local address of the router. So I hit enter, and you see now my PC is communicating with the router through this link local address. Again, this address is not routable, means this address can only be used within the same subnet. Okay, so my router and PC, they both have a link local address. They can talk to each other. If you still remember my demo, when I deal with these two devices, I configure the router by just enabling the Ipv6 interface. I didn't enter any address or even the subnet prefix, subnet mask. I didn't tell the router anything. I just tell the router that now you turn on the Ipv6 for me for this interface, and the router will generate the link local address for the interface for the local subnet communications, and the PC will do the same thing. Okay, so any Ipv6 device, when it turn on, it will generate the link local address for the local segment communication. So with these three demos today, the manual IP address configuration. Let's go back to my slide. The manual IP address configuration, you manually enter the IP address for the interface for the global unicast address, and you can also do it automatically by enabling the EUI64 for the interface config, and go to the PC, turn on the auto config, and the PC will ask what address I should use for this subnet. So these two ways you can configure the IP address for your device, automatically or manually. And don't forget that other than the global routable address, the global unicast address, each interface, when you enable Ipv6, you will also be getting a link local address for the local communication. It is like the IPv4 169.254/16 addressing. It's easy for you to remember what it is. It's for local communication only. So before I move on to Anand and Liu Kan's part, just show you a quick configuration here for your reference. When you turn the IP address auto configuration, turn on the auto configuration, all you need to do is just specify the network portion of the address and make sure you enter the keyword EUI64. And don't forget, enable the interface IPv6 as well. And very importantly, make sure your interface is in no shut state. Then you don't need to worry about the interface address. The router and the PC, they will do automatically for you based on the auto configuration capability of the IPv6. And one very important thing, when you do a show interface, make sure it's IPv6, not IP, because IP command on a router is for v4. If you do deal with anything IPv6, put a v6 there. Okay, that's all I want to show for my first part. It's a very basic, simple things. And now we will move on to Anand to talk about how we set the routing, static routing on our IPv6 network. So I'm going to pass my time to Anand.